Hey everybody, my name is Mike Deal. I'm your instructor for AIT 1401 Basic Electrical Control. Okay, this is basically Motor Controls 1. All right, in this class we are going to learn to stop, start, jog, reverse, and also control the speed of the motor. In this class we're not going to worry too much about controlling the speed. That's going to come in AIT 1501, but you're going to want to be able to know that we're going to start, stop, and jog, and reverse the motors in this class. The other thing too is you're going to want to make sure you take really good notes. Why? Is because number one, in the lecture and the reading material, any other material that I've got online for you, there's some critical information and you're going to need to take notes. A lot of it's going to be on the quizzes, but more than anything, I want you to learn this material, not memorize it, because I promise you, the material that you're learning from week to week is going to build on each other. Okay, so memorizing is not going to cut it. So I'm going to need you to learn it. Frontwards and backwards. I'll help you any way I can, but also as you come to lab, you're going to be asked some questions specific to what we were dealing with as far as the lecture, or maybe what you read. So you need to be prepared when you come to lab. Yes, and there's the quiz as well. You want to be prepared for the quiz. Those are important, but I'd much rather you learn the material than memorize it and do well on a quiz. I'd rather you learn it, okay? But again, just taking good notes on your reading and the lecture material is going to be critical. Also, it's going to be critical that you take good notes in lab as well, okay? So whether you know it or not, you've probably already dealt with motor control in some way, form, or fashion. If you've got a garage door, for example, that opens and closes, you press a button and you walk away from that button, and the motor continues to drive the door up until it reaches a certain point, and it'll drive it down till it reaches a certain point without you having to stand there and hold the button. That's motor control. All right. Some other examples would be with your HVAC system in your house. You've got the heating or the air conditioning system that if you have a thermostat on the wall, you press the button to the desired temperature that you want, and then a motor comes on that turns the compressor on, and it also runs the fans for the evaporator and the condenser coils. All right, so that's motor control as well. If you've got a compressor around your house and you do some work with pneumatic tools, for example, or something like that, you've got a compressor that is, the motor that turns the compressor is controlled by some devices that tell it to turn on and shut off based on the pressure. And finally, you've got in your vehicle, when you turn the key switch on your steering column, that energizes a coil. It brings voltage across a set of contacts and makes a motor turn, which then engages with the flywheel of the engine and starts to turn the engine over so that it will start. So that's motor control as well. In industry though, motor control is used specifically for turning compressors, giant air compressors, pumps, whether they be hydraulic. We have some screw conveyors. In the coal industry, if you've got conveyor belts, also in manufacturing, there's conveyor belts that moves product down the line in manufacturing as well. But in our class, we're going to deal specifically with three-phase voltage motors, okay? And why are we going to do that? Well, basically what we want to do is we're wanting to take three phases of voltage that are delivered from the power plant, L1, L2, and L3, okay? That stands for line 1, line 2, and line 3, all right? And we're going to provide voltage across these lines right here. And these lines are conductors. Now, as we go through the class, you're going to make sure that you understand what the symbols are. Okay? In this particular case, these heavy three black lines are the power lines coming up to feed the motor. Okay? This is a three-phase symbol for a three-phase motor. You want to make sure you know that too. But this is a three-phase motor. We brought power up to this point. Now we've got to get power to the motor. That's pretty much simple. That simple. So we want to bring it to here and we'll get to the motor. How we do that is going to get a little creative, and it's also kind of what makes this class a little bit more interesting too. So again, we're going to only deal with three-phase motors in this class. One of the reasons is that three-phase electrical systems are the industry standard. When you're talking about in industry, manufacturing in particular, coal mines and things like that, your power is going to be three-phase. You're not going to run a lot of single-phase unless it's for control or some lighting and things like that. But for moving heavy equipment or things with big electrical motors, you're going to use three-phase power. Okay, and we also use three-phase electric motors because they're typically smaller in size than a single-phase motor that tries to deliver the same amount of horsepower. Okay, so if a 5-horsepower three-phase motor is going to be smaller in physical stature than a single-phase 5-horsepower motor. Okay. Also, Three-phase motors do not require the use of starting aids such as capacitors and start windings and things like that that are typical of a single-phase motor. So there are fewer things to fail, all right, and fewer things to go bad. And also, three-phase motors have a higher starting torque than a single-phase motor will. Okay, just a quick pictorial example here. We've got these single-phase sine waves here. Okay, and you can look at these as power pulses, so to speak. Okay, these are the power pulses that hit the motor, and you've got one every 180 degrees. And with a three-phase power system, you'll have one every 120 degrees. You got more power pulses hitting that motor in a given amount of time. So that's going to give us more starting torque, and again, we're going to be able to do away with some of the starting aids. For example, this is a single-phase motor. I'm going back to this picture here. We just have line one and a neutral, so it's just a single-phase system. And we've got a capacitor, a centrifugal switch, we've got start windings, we've got main windings. All these things are subject to fail, whereas the three-phase motor doesn't have nearly that many components, yet it does the job much more efficiently, and it does it better too. So again, we're going to deal with strictly three-phase motors. This is just kind of an introductory video just to kind of get you started, give you an idea of what we're going to be dealing with and why we're dealing with it. Okay, we're starting down with the bare bones here. Before we get into any type of motor control, I want you to understand what it is you're trying to control. We're going to talk about the three-phase motor. We're going to talk about three-phase power plant systems. Okay, where's this three-phase coming from? It's imperative that you know where it's coming from, how it's created, how it's developed. We're not going to get real deep into it, but I want you to understand why we are dealing with three-phase, where it comes from. When we plug something up into the wall, we magically have three-phase, but we need to know where it's coming from because it'll also help you with troubleshooting and diagnostics as well. So we're going to talk about three-phase power supplies, and we're also going to be talking about three-phase motors in more depth. But this is just an introductory video. Again, the biggest thing is to take notes in the lectures. I didn't give you a whole lot to take notes on this one, but in the coming lectures, be sure to take notes and be sure to highlight or take notes in your reading. Oftentimes, people find that highlighting is good, but also if you will take notes as you write and write down notes as you read, that helps you stay with you a little bit better. And take notes in the lab too, so because all these things are on your quiz, but the quiz I'm not so worried about. I want you to learn this rather than memorize it, because these classes, these lessons will build on each other. And if you don't understand it from a fundamental level, it's going to get harder and harder and you get more and more lost. So I don't want that to happen. So take notes, and if you do have any questions or any problems or you don't understand something, by all means, come in the lab, see me, stop by my office, send me an email. I'll bend over backwards to help you as long as you're trying to help yourself. I assure you that, okay? So again, this is a little introductory video. Hope it's been helpful, and go on next to the power plant and then the three-phase motor, okay? So good luck in the class.